Hello everyone, welcome you all in my YouTube channel. I am Dr. Mohammad Sirajul Faizi, Assistant Professor, Department of Chemistry, Langat Singh College, Muzaffarpur. Today in this video, I will explain about reactions, introductions and application of amine. So, we will start with the introductions of amines. You know that compound containing nitrogen, either this is the primary, secondary or tertiary amine. Amines are one of the most important classes of organic compound, which can be derived when we replace one or more hydrogen atoms of ammonia molecules with an alkyl groups. So you know the ammonia. The formula of ammonia is NH3. You can replace all three hydrogen with alkyl groups. Then you will get primary, secondary and tertiary amine. So an amine is generally a functional group with a nitrogen atom having a lone pair. Amines resembles ammonia structurally, where nitrogen can bond up to 3 hydrogen atoms. It is also characterized by various properties that are based on the carbon connectivity. So amines are organic compounds that contains nitrogen atom with a lone pair. Basically, they are derived from the ammonia, in which one or more hydrogen atom is replaced by alkyl or aryl groups, and so they are known as alkylamine and arylamine respectively. It depends on the R. Now focus on this point here. You see primary amine. Nitrogen contains 2 hydrogens and 1 carbon. This is the secondary amine. Nitrogen contains 1 hydrogen and 2 alkyl. This carbon, this carbon. Now this is tertiary amine. Nitrogen contains 2 methyl groups and this is also carbon. And this is ammonium salt, quaternary ammonium salt. So you see nitrogens have 3 hydrogens in the attached with this carbon. So nitrogen has positive charge, and this positive charge is counterbalanced by this chloride ion. So what is the conclusions? The primary amine contains 2 hydrogens associated with the nitrogen, secondary 1 hydrogens, or tertiary no hydrogen, and quaternary have 4 carbon, and ammonium has 3 hydrogens of carbon. So this is what? Primary, because NH2, this is primary NH2, NH, this is secondary, and without hydrogen, this is tertiary, this is primary, and this is also primary. So this is aniline, benzylamine, and so on. So nitrogen has 5 valence electrons, and so is trivalent with lone pair. As per valence shell electron pair repulsion theory, nitrogen present in amines is sp3 hybridized, and due to the presence of lone pair, it is a pyramidal in shape instead of tetrahedral shape, which is generally structure for most sp3 hybridized molecules. So each of the 3 sp3 hybridized orbital of nitrogen overlap with the orbital of the hydrogen or carbon depending upon the configurations of amine. Due to presence of lone pair, the carbon nitrogen hydrogen angle in amine is less than 109 degree, which is a characteristic angle of the tetrahedral geometry. The angle of amine is near about 108. Now you see here, this is nitrogen. It is in trivalent, this bond, this bond, this bond, 1 lone pair. These are maybe same, maybe different, It is not a tetrahedral, so it look like pyramidal. This wedge bond showing towards you, this broken bond showing behind you, and this is normal bond. Now you see two hydrogens, so this is primary amine. Here one hydrogen, this is secondary amine, and no hydrogen, this is tertiary amine. So this is sp3 hybridized, this is sp3 hybridized, sp3 hybridized. We just check it, 108 degree, 107 degree, 107 degree. So primary, secondary and tertiary. Now occurrence of amine. Naturally amines occur in protein, vitamins, hormones, etc., and they are also prepared synthetically to make polymers, drugs and dyes. What is the uses of amines? Amines have widespread application in our daily lives. Some of the use of amines are: it is used in water purifications, medicine manufacturing, and development of insecticides and pesticides. It is involved in the productions of amino groups, which is building block of protein in living beings. Many different varieties of vitamins are also made by amines. Serotonin is an important amine that functions as one of the primary neurotransmitters. It controls the feeling of hunger and critical for the speed with which the brain operates in general pain relieving medicine such as morphine, demerolwhich, which are also known as analgesics, are made from amines. So we already discussed about the types of amines. On the basis of how the hydrogen atom are replaced by an ammonia molecules, amines can be divided into four types. You can see this is ammonia, this is primary, this is secondary, and this is tertiary amine. So primary amines, when one of hydrogen atoms of ammonia molecule is replaced by an alkyl or aryl groups. The examples of primary amine is methylamine and aniline. Secondary amines, two or organic substituent replaced by hydrogen atom of the ammonia molecules, forming an amine, dimethylamine and diphenylamine. Tertiary amines, when all three of hydrogen atom are replaced by an organic substituents. It could be an aryl or aromatic groups, trimethylamine, ethylene diamine tetraacetic acid, EDTA, well known. Cyclic amine, these are the secondary or tertiary amines in an aromatic ring structure, example piperidine and aziridine. So basicity of amines. Similar to ammonia, primary and secondary amines have protic hydrogens and thus they showcase a degree of acidity. Whereas tertiary amines have no protic hydrogens and thus do not possess a degree of acidity. pK values for primary and secondary amines is about 38, which makes them a really weak acid, whereas if we take the pKb is about 4, this makes the amine much more basic than acidic. Thus an aqueous solution of an amine is strongly alkaline. So preparations of amines. You can prepare amine with the help of acid chloride, ammonia. You will get the 1 degree amide, CONH2 group is known as amide. On reductions and reactions water, it gives 1 degree amine or primary amine. Acylation of a starting amine by an acid chloride gives an amide with no tendency toward over alkylizations or acylations. Reductions of the amide by lithium aluminum hydride gives the corresponding amine. You can see if you have this type of amide, you will get the primary amine. If you have N-methyl substituted amide, you will get the secondary amine. If you have NN-dimethyl, then you will get tertiary amine on reaction with lithium aluminum hydride. If you have alkyl halide, it will react with sodium cyanide, you will get cyano group. On reductions with aluminum hydride, you will get the 1 degree amine. And same as if you have carboxylic acid, it reacts phenyl chloride and ammonia, you will get this amide. Or you know the amide reduction, you will get the 1 degree amines. So if you have the ketone, then on reductions with amine, hydrogen catalyst, primary amine. If you have primary amine react with ketones, you will get the secondary amine, and if you have secondary amine, it react with ketone, you will get the tertiary amine. So that one is also very important, Gabriel amine synthesis. If you have the alkyl halide and this compound, you will get the primary amine, and this one is also one step creation. So this is the mechanism how alkyl halide, this lone pair approach on this carbon, it acts as nucleophile and then replacement of Cl- and forming quaternary ammonia, and this quaternary further react with another ammonia, it gives ammonium and CH3NH2, and on reductions you will get amine and water. Same way, this is amide already seen. So what will happen here? This is acid chloride react with sodium azide. You see the N3 is azide. On rearrangement you will get isocyanate, and this isocyanate react with water, you will get the 1 amine, 1 degree amine. Cyanide reduction lithium aluminum hydride. Yes, this is not the alcohol, this is amine. You can see 1 degree amine always react with aldehyde and ketone forming ship base, which is amine. Now you see methylamine react with water forming this ammonium, and this ammonium. Reaction of secondary amines with water, secondary amine. Reaction of tertiary amine with water, so quaternary amine. You see 1 degree amine react with ketones, hydroxylamine, they are forming amine and alkyne. This is a special functional group, carbon double bond nitrogens and carbon double bond nitrogen, here CH3 amine OH oxine. Same hydrazine, you see NH2 hydrazine, if NH semicarbazone, if you have semicarbazide. And this is cyclic form, this is the keto form, enol form. If you have amide, so amide imidic acid. If you have lactam, so a keto form. If it is in a form, lactine, like that. So friend, hope this video will be helpful to you. If you like this video, then subscribe my channel, share it with friends. Thanks for watching.